everyone. C13NMR carbon isotope 13, which has a natural abundance of 1.1%. Today we are doing calculation of chemical shift of alkenes. In my previous videos, I have done calculation of alkanes as well as in detail about C13NMR. First of all, let me tell you what is chemical shift. It is the difference in the absorption position of a particular nucleus from the absorption position of a reference nucleus. Normally, that will be taken as TMS. TMS stands for tetramethylsilane, which is used as a standard. This is called as chemical shift. Chemically equivalent carbons have same chemical shift. Now the shift in absorption occurs due to the difference in effective magnetic field experienced by different sets of nuclei, which is mainly dependent on the chemical environment of the nucleus. Do check my previous videos for in detail study about chemical shift. Now let us go into the calculation of chemical shift of alkenes. In general, chemical shift of terminal alkene carbon is upfield than internal alkene carbon. So you can say normal range of chemical shift is around 110 to 150 ppm. These are all the values that we will be using. Now how we do for alkenes? Alkene is a double bonded carbon. So carbon 1 and carbon 2, in between these double bonds, we will take them as starred carbon. Left side of the starred carbon, if we are taking this carbon as carbon 1, then on the right side we will write down alpha, beta, gamma, and we will take these values. On its left side, we will leave the star carbon and we will take alpha hash, alpha 1, beta 1, gamma 1. To do the calculation, chemical shift of alkene carbon base value will be 123.3. This is the base value to which we will add the additive shift due to alpha, beta, alpha or alpha 1 or beta 1, gamma 1 plus the Z correction, or you can say plus the Z cis correction. So in this way we will do the calculation. Let us start with an example. An example of 3-methyl-2-pentene. Let us put the star on the carbons. In between the double bond, we get a star. Now, let us calculate shift for carbon 2. This is carbon 1, 2, 3, 4, 5. This one is 6. In molecular formula, this one will be 6. So now C2 carbon will have 1 alpha, this side carbon, it will have 1 alpha 1. So this side also will be alpha 1. After alpha 1, this is beta 1. So for C2 carbon, we have the base value as 123.3 plus 2 alpha carbons plus 2 alpha dash carbons, 1 alpha carbon and 1 beta carbon. Let us substitute the value plus the Z correction. Let us substitute the values. 2 alpha dash carbons, alpha dash is minus 7.9, 2 into minus 7.9, 123.3 plus 1 alpha, alpha is 10.6 plus 1 beta dash, that is minus 1.8 plus the Z correction, that is minus 1.1. Now let us do for carbon number 3. Chemical shift for carbon 3. Now since we are counting on this side, these sides will become alpha. This is alpha. If this is alpha, this will become beta. If this is alpha, the carbon next to the star carbon will be alpha. So on the opposite side of the star carbon, this will become alpha 1. So carbon 3, we will have 123.3 as the base value plus 2 alpha carbons plus 1 alpha dash carbon plus 1 beta carbon. Let us substitute the values plus Z correction, that is 123.3 plus 2 into plus, that is 142.7 ppm as calculated value, which is very near to the observed value of 137.2 ppm. In the same way, we can do the calculation of other alkenes. Till then, keep watching. If you like my videos, do give it a thumbs up and don't forget to press the bell icon to get the latest uploaded video notifications.